On page 2, I have a mapping done so that we can see how this insurance policy would be paid out if it ever had to be paid out. Okay, so if you take a look at this, I've got this table built on page 2. It takes up the entire page. So let's talk a little bit about what I have here. So the column headers are payment, beginning balance, deduction, and ending balance. And if you look in this first column, it is keeping track of which payment is made to the wife and child. So remember, if this insurance policy had to be paid out, there would be a payment done every year for 35 years. So if you look at this first column, the payment numbers are 1 through 35, okay, because there would be a payment every year for 35 years. There would be a total of 35 payments. So that first column is just really keeping track of which payment is being made, okay? So remember I told you you can think of this life insurance policy as like an account that John's wife and child would be paid out of. So that every time that there is a payment, there's going to be a beginning balance to the account, okay, and that's going to be in this column. And then there would be a deduction of $35,000, okay, a payment made to the wife and child. So if you look at the deduction column, every time there's a deduction or a payment made to the wife and child, it's going to be $35,000, okay? And then after that deduction is made, there is an ending balance to that life insurance account, okay? So that's kind of what's going on. That's what the columns are keeping track of, okay? So like I said, we're going to use this table to see how John's life insurance policy would be paid out if it had to be, okay? All right, so at the end of example 1, if I go back to this page, we decided that this is how much life insurance John needed, okay? Exactly $468,407.35, okay? This is the amount that the life insurance policy would have to start out with in order to pay out John's wife and child the $1,225,000 over the 35-year period, okay? So if I go to my table, okay, I'm going to go ahead and write the very beginning balance right here in this shaded box, okay? So it's $468,407.35, okay? So like I said, you can think of this insurance policy as being an account out of which the wife and child are paid, okay? This is going to be the very beginning balance of the account, okay? All right, this is an annuity, okay? So the wife and child will be paid regular payments, okay? So that's what makes this an annuity, okay? Remember, we are only studying ordinary annuities, okay? With an ordinary annuity, everything is done at the end of the period, okay? So when this one lump sum is invested, okay, it sits there for an entire year, okay, and it earns interest. And so then what would happen at the end of 1 year, there would be an interest payment, okay? So what's going to happen here is I'm going to put a line here and a line here because nothing is going to go there, okay? But this one lump sum that's been invested, it is going to sit there and earn interest for a year, okay? So this sits and earns interest for a year, okay? So that 1 year time frame, that money sits there and earns interest, okay? And then it's time to make the first $35,000 payment to John's wife and child, okay? Before we can do that, we need to see what is the starting balance, okay, when it's time to make that first payment, okay? Because again, it's going to be a different amount than this $468,407.35 because that money has been sitting there for a year earning interest, okay? So I'm going to go out to the side over here, and I'm going to calculate what this new beginning balance is going to be, okay? All right, so this money has been sitting there for 1 year, okay? That's a short time frame. So I know we mentioned this when we did simple interest. Simple interest works for a short time frame, okay? So what we're going to do here is we're going to use a simple interest formula to figure out what this balance is right before the first payment is made, okay? Remember you had two simple interest formulas, I equals P times R times T, and then you had the other one, and that's the one I'm going to use, which is the A equals P times 1 plus RT. I'm going to use that one so that I can just outright get my account balance right before it's time to make the $35,000 payment, okay? Um, you could also use the I equals P times R times T. That would give you the interest, and then you would just have to add it back to the original amount to get your account balance. Okay, so let's figure this out. Okay, so the account balance right before the first payment is made, okay? Well, the p-value is how much we started with, okay? The account started with $468,407.35. We've got to multiply that by 1 plus the interest rate, that is 0.067 times time, okay? How long did this $407.35 sit there and earn interest? Well, for 1 year. Okay, so time in this situation would be 1 year. Okay, so that's how you would set this up. Okay, and then I'm going to go to my calculator and I'm just going to calculate this. Okay, so if we did this, it's going to be $468,407.35, open parentheses, 1 plus 0.067 times 1. Okay, and this tells me right before I make the first payment, okay, this is how much is in the account, okay? And I'm just gonna go ahead and round this to the nearest cent on the calculator. We've got 64 cents. There's a 2 that comes after, so we're just gonna keep it at 64 cents, okay? All right, so if we go back to our notes, I'm gonna jot this down, okay? And then I'm gonna fill in the table, okay? All right, so when it's time for the first payment, right before we make it, because this red amount has been earning interest, okay, the balance right before the first payment to John's wife and child is made is $499,790.64. Okay, so then we make the first payment to the wife and child. Okay, that is going to be a deduction. We're paying out $35,000 from this $790.64. Okay, so after the first payment is made, how much is left in the account? Well, all you have to do is take this amount, the $499,790.64, subtract out the $35,000, and after the first payment, that's how much is still sitting in this life insurance account. Okay, so let's go ahead and do that. Okay, so I'm going to go ahead and do the subtraction here. Okay, got to use dollars and cents, so I need to use the rounded version here. Take out 35,000. Okay, this is the ending balance of this account after the first payment has been made. Okay, so I go ahead and jot that down in the table. Okay, all right, so the ending balance is $464,790.64. Okay, so what happens now? Well, this money right here, this balance, sits here for another year. Okay, we don't make another payment until another year has rolled around. Okay, this amount will sit there and earn interest. Okay, so I'm going to go ahead and we're going to calculate that. Okay, we're going to calculate, okay, if this money sat here for 1 year, okay, what would be the new beginning balance right before we made the second payment? Okay, and I'm going to put this in a different color so you can kind of follow where these calculations have come from. Okay, again, this money is going to sit in there for a short time frame, a 1 year period. So I'm going to use another simple interest formula on it. This is going to be green. Hopefully you can see that. Okay, so I'm going to use my same simple interest formula just to calculate how much money is in the account right before the second $35,000 payment. Okay. All right. So if we do this, let's see. This time our beginning balance was $464,790.64. That's how much money was sitting there earning interest. Okay. Times 1 plus same interest rate 0.067 times the money sat there for another 1 year period. So time would be 1 in this case. Okay. All right. So I'm going to go to my calculator and calculate this. Okay. So let's see here. We're going to have 464, 790, 64, open parentheses, times 1 plus the interest rate times the time. Okay, this is going to tell us the beginning balance right before the second payment is made. Okay, again, this is going to be dollars and cents. Okay, so we need to go ahead and round this to the nearest cent. Okay, we have 61 cents and there's a 2 that comes after, so we need to keep it at 61 cents. Okay, so jot this down. Okay, here is your balance right before the second payment. All right, and that number will go in the table right here. Okay, so again, okay, that is how much we're starting with right before the second payment is made. Okay, so then it's time to make another $35,000 payment to John's wife and child. Okay, so right after the second payment is made, we can calculate the ending balance at that point in time. So again, all we need to do is take this amount, the $495,931.61, and subtract out the $35,000. Okay, so let's go do that. So let's see here, I'm just going to type it in. Again, using it rounded appropriately to dollars and cents, subtract out the 35,000. Okay, so right after the second payment is made to John's wife and child, there is a total of $460,931.61 in this life insurance account. Okay, so that is going to go right here. Okay, and you would just keep doing this. Okay, so I've kind of filled in the rest of the table for you. Okay, I'll do one more calculation just so you can see where this number comes from. Okay, and then after that, it's just the same process repeated over and over again. Okay, so to get this last number, I'll go ahead and put that in, I don't know, I'll put it in gray. Okay, so how do we come up with this number in yellow? Well, again, what's going to happen here, this $460,931.61, that's how much money was in the account right after the second payment had been made to John's wife and child. So now that amount is going to sit there and earn interest for a 1-year period. Okay, so what we're going to do is we're going to go out to the side. Okay, so right before payment 3 is made, we need to know what the new beginning balance is. Okay, so we're going to do our P times 1 plus RT. Okay, so $460,931.61 sits there for a 1-year time frame earning interest. Okay, so we're going to multiply this by 1 plus 0.067 times 1. Okay, so let's go figure this out. Okay, so we're going to have $460,931.61. Okay, so we're going to multiply that by 1 plus R times T. Okay, there you go. Okay, this is the balance in the account right before the third payment is made. Okay, we're going to go ahead and round this to the nearest cent. Okay, so we have 2 cents. There's a 7 that comes after, so we need to bump this up to 3 cents. Okay, so this is going to give us, let's see here, $491,814.03. Okay, and that is the number that you see in yellow. Okay, that is this number. Okay. All right, so then, the table would carry on. Okay, so that's my beginning balance right before the third payment. Then we make the third payment of $35,000. Okay, you subtract these two numbers to get the ending balance. Okay, and then it keeps going. Okay, this amount would earn interest. Okay, over a 1-year period, which would bring the balance up to this number. Take out the $35,000, then get the new ending balance, and you just keep doing this. Okay, for 35 years. Okay, so like I said, I have filled out the table for you and you get all the numbers. Okay, all I did was pop this into an Excel spreadsheet to calculate this. Okay, but this is how it works. Okay, so if we scroll down, okay, there's a couple of things to notice about this table. Okay, so again, the first column, tracking the payments, there are a total of 35 payments. Okay, in the deduction column, every time there is a deduction of $35,000. Okay, and what you can see here is you can look at how the beginning balance and the ending balance compares over time. Okay, if you look at the beginning balance, that beginning balance column, okay, you can see how it goes down, 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 down. Okay, and when it comes time to for the last payment, okay, it's got just enough in there. It's 6 cents short, okay, but due to rounding, okay, but it's got just enough in there to make that last payment, and then you make that last payment and you've zeroed out the account. And again, we're short by 6 cents, but that's not too big of a deal in the grand scheme of things. Okay. So what you can see happens here is if you look carefully at this table, what has happened? Okay. We started, all that had to be initially put in the life insurance account is $468,407.35. Okay. And what happened here is every year that account balance would earn interest and bump up the account value just enough so that it could keep it afloat, so that we would be able to make these $35,000 payments every year for 35 years, okay? And it did that in such a way that we had just enough in the account at the end of the day, okay? We didn't have this extraordinary balance left over. It zeroed out the account, okay? And by doing so, if you add up this deduction column, okay, it paid out John's wife and child $1,225,000. Okay, so that's exactly how this present value of an annuity formula works. This is what's going on behind the scenes. Okay, in calculating the present value of the annuity, you figure out the one lump sum that you have to invest so that the annuity can be paid out over time. Okay, so I hope this example helped you understand what this formula is doing and what it means. Okay, again, the two big things for this type of problem, okay, present value of an annuity, okay, life insurance, what we just saw, and retirement. Okay, so in the next few examples, we're going to look at how this formula is going to help you save for retirement.